Hello and welcome to Morehouse's Math Menagerie, where outliers are always welcome. Today, we're going to continue talking about sampling distributions for a proportion. We will continue to talk about the proportion of students who graduate from Timberline and attend college in state. Out of all students who attend college after graduating from Timberline, 67% attend college in the state of Idaho. Now, just like in the previous videos, we've been simulating taking samples of size 40 students from Timberline. So as we generate a couple thousand students here, a couple thousand samples of size 40, you'll recall that we get an approximately normal distribution here that's centered at the population proportion 0.67. We're pretty close there. Let's take another 1,000. And we get almost exactly 0.67 here. Now, one thing I want you to notice, we've talked about shape, it's approximately normal. We've talked about center, it's the population proportion. Now we want to talk about spread. You will notice that these sample proportions go from about 0.45 to about 0.9. So we get a range of 0.45 from 90.9 to 0.45. Now, what would happen to that spread if we changed the sample size? So let's change the sample size up here to 200, like we did in the previous video. And let's take several thousand samples again. So let's go up to 3,000. Here, we are getting about, it looks like, 0.56, we'll say 0.56, to about 0.79. So 0.79 minus 0.56, we would get a range of about 0.23. So our range got quite a bit smaller in our sample proportions. Well, let's change it to an even higher sampling size. So if we did, let's say, 400, and let's take several thousand samples again. Here, let's go with blue, we get about 0.6 to about 0.75. So 0.6 minus 0.75, we're going to get about 15 here for our spread, our range, I should say. You'll notice that every time we increased the sample size, our spread went down. That's because, as we've talked about before, as you increase sample size, you decrease variability. So increasing sample size decreases variability for sampling distributions as well. If we were going to talk about standard deviation of our p-hats, there's a not very good sigma there, but we'll go with it. This is going to end up equaling the population from the proportion times 1 minus that population proportion divided by the sample size n, all square rooted. And you'll notice here that even within the formula, the idea of increasing sample size decreases variability because n is our sample size and we're dividing by it. So the larger n becomes, the smaller the standard deviation is going to be. So to recap, the larger the sample size, the smaller the variability for the sampling distribution. And the standard deviation of our sample proportions, the standard deviation of our p-hats, is the square root of p times 1 minus p divided by the sample size n. I hope you enjoyed today's video. Thank you for joining us and have a great day.